Welcome back, everybody. You're listening to the next to the last episode of Breaking Down Security for this season. I'm Brian Brake. With me is Ms. Berlin, as always.
Hello.
Mr. Betcher is not here. He's probably
MIA.
Well, he's probably out, wassailing or whatever it is that people in Texas do at this time of year. They're not putting up, de-icing or anything. So,
right.
Yeah, it's Sunday for him, and it's, the 9th of December after DerbyCon, so I'm kind of sounding like crap, I know. So apparently I got con flu for being in the same room with a bunch of people for 8 hours and then leaving. So HushCon was great. I loved HushCon.
Yeah.
A lot of great discussions, a lot of next level discussions. I mean, there was some really high tech stuff going on there with, reverse engineering and such. And, the stuff that I'm, it's one of those things where they need to talk to me like I'm 5 years old. Otherwise I don't get it. So,
put the audience in my eyes glaze over.
Yeah. Well, thankfully I work with one of the guys that, was giving one of those next level talks. So I'll get with Elfmaster, and see if he can, explain to me like I'm 5 or something. So, Ms. Berlin, you going anywhere for the rest of the year, or are you stuck at home?
As far as cons, no, I'm not going anywhere until Shmoo. But I'm taking my kids. They don't know this yet. I'm taking my kids to Chicago.
Oh.
I got them tickets to do the indoor skydiving thing.
Oh, wow. Okay.
In the big tube.
Okay, very nice. Yeah, we have one here in Tukwila, which is south of Seattle. The iFly or something like that.
Right. Yeah, the closest one to me is Chicago, which is a five-hour drive.
Oh, yeah. Okay.
But we're just going to stay in Chicago for the weekend and hang out and do stuff.
That's not bad either. You go see Lake Michigan, make sure you're not going when it's, going to be lake effect snows or anything.
Yeah.
Yeah.
I mean, it's 2 weekends from now, so maybe.
Oh, wow. That's like really close to Christmas then.
Last year, this time I drove to Buffalo, and that was the worst idea ever.
Oh. Yeah, that's not good. That's not good. So the only people who go to Buffalo are people who are actually going to play football or American football or anything.
Right.
Yeah, that's the only reason to go there. Yeah, this time of year. So, right on. Well, I'm gonna go ahead and get us started on our interview this week. So, for those of you who are regular listeners of the show last week, which is for us only about 3 days ago, we recorded a conversation with a gentleman, Adam Baldwin, who's the director of security for NPM, Node Package Manager, one of the most popular Node package managers, Node.js package managers out there. And we learned quite a bit about that, it's worse than herding cats. It's like herding air. You can't really do anything with it, and developers are going to do what they want to do. And, it's really beholden to us blue teamers to, do NPM audit and to look at those, items and to see if there's anything that your environment is using that may be, having issues. Even doing regular NPM audits of those things would be helpful. The gentleman we have on this week, his name's Mike Samuels. He actually reached out to us before Adam Baldwin, but we had Adam on to talk about the event, the flat map stuff, which kind of came up at the same time. And I thought, this will be great because we're going to seg right from, the package manager people to somebody who's actually trying to harden Node.js on the back end. So, Mike, welcome to the show.
Thanks so much for having me on.
Cool. So, Mike, maybe you could tell people a little bit about yourself, how you came to be where you are, maybe what your title is at that search engine company, the small search engine company.
So, I work for Google. I'm on the technical infrastructure team in security engineering, and we are responsible for making it easier to produce secure and robust software. So, we've done a lot of work trying to improve libraries, improve compilers, type systems, the whole software engineering tool chain to make it, what our goal for a long time has been, if it's not secure, it doesn't compile.
Right.
But I've been working a lot on dynamic languages like JavaScript, where I've been trying to make it so that if it's not secure, it doesn't emit anything. And I've been working a lot on Node.js because that's one of the most popular dynamic frameworks out there. JavaScript, of course, runs on both the server and the client. So if we can come up with a way to make it easy to produce secure JavaScript programs, then that has a lot of downstream benefits.
And that sounds like a bit of an oxymoron, secure JavaScript programs. So what's the current landscape look like right now? Is there a way to secure anything, or the controls you're planning on putting into place, additional security measures that should have been in there but were never in there in the first place?
Yeah. So you mentioned blue teamers. So my goal is to make it much easier for an application team in conjunction with some security specialists to produce secure software. And so with Node, the nice thing about Node compared to the client is that we actually have a module system. And so I think with the event stream vulnerability, we've seen where a module system can become a vector for attack. If you can update a dependency and then people if you can push a malicious version of a widely used dependency, then you can get your code potentially into a lot of places and do a lot of damage. But the module system actually also gives us an opportunity. We can start thinking about what are the sources of abusable authority. For example, Node's HTTP package has APIs that can be abused or misused. Node's child process package, which allows you to spawn a shell, can be, that's error prone as well. A lot of people unintentionally leave themselves open to shell injection. But it's almost no modules need access to all of these sensitive modules, all of these modules that have, that are error prone, even when, used by well-intentioned code. So what we can start saying is, the security specialists can come up with a list of sensitive modules and start thinking about which user code actually needs access to these. So, for example, the event stream bug used the HTTP package to exfiltrate stolen wallet passwords, I believe. And it also mucked. I think it also used the FS package to deal with a file system, and it mucked with a bunch of other internals. Like it changed, I think, how it overwrote the module compile to hook into that and get privileged access to the internals of the copay module. But usually, when you start thinking about a particular class of vulnerabilities, you can figure out that there's a couple pieces of code that must be involved, or most likely are involved in that vulnerability. For example, any client-side XSS is probably going to go through response.write. So we can identify these choke points. Then we can start thinking about how do we guard those choke points. Sure. Once we've got a set of mitigations, we can start rolling them out, and the security specialist, the blue team, would end up maintaining kind of lists of which modules need access to what.
Right.
And that gives us a way to say different modules have different privileges, gets us a lot closer to, the principle of least authority.
Right.
On that list, do you have different severities, I guess, of modules? Like you mentioned HTTP 1, like that would be, super bad, right? If somebody got malicious code into that. But do you have a ranking of the more important ones that you have to worry about? So
HTTP almost always figures in exfiltration. If you want to leak something, you tend to use that. Exfiltration is actually really hard to solve because of side channels. You can leak a lot to logs, you can leak a lot to other places, and then if you can write to the file system, you can write to a file under the temp directory, and that means if you can also get even non-privileged a non-privileged process running on that same machine, you might be able to exfiltrate it the other ways. But locking down HTTP is kind of a no-brainer. Typically, in applications I've seen, the only things that use HTTP are a couple modules that are related to kind of event processing, or the module which spawns a server or something that is dealing with, it's connecting to specific REST APIs out there. And child process is similarly a no-brainer. Not everything needs to be able to spawn its own child process. There's a surprising number of things which spawn child process just so they can get the list of files in a tarball. That's a good thing. It's fine to whitelist those after you've looked at it. So maybe you see a bunch of those in different projects, and just having the blue team know that that's something that's worth looking at. Just bounding the amount of code that they need to look at gets them a lot closer to confidence that there's not going to be shell injection.
Yeah. So it sounds like you're trying to do, like for PHP what Suhozen or whatever those were doing by adding additional code. You're actually hardening the Node.js backend. Well,
so doing differential privilege for modules is one part of it, yeah. And so we hook into the module loader process when there's a require from a common JS module or an import from a TypeScript or ES6 module. Then some trusted code runs, and it's basically answering the question: what module is allowed to connect to what other module? And in the vast majority of cases, we don't do anything. I'm also trying to, if an attacker can get a file onto the file system, we don't want them to be able to execute it. So we do resource integrity checks using these hooks. But then we also kind of prune the link graph and say, for these sensitive modules, only certain other modules are able to connect to them. And so that gives us a place to stand to move, to guide the developers away from error-prone modules that have, when you have an error, it has security consequences, towards safe APIs that map those modules. But the second big thing is to use the type system to our advantage. So JavaScript is not a statically typed language. TypeScript is a statically typed language, but it's unsound. So we use runtime types. If you want to prevent client-side XSS, for example, you want to control, you want to make sure that the only things that go out as part of the response body for an HTML response is something that you trust. And so we come up with a type that represents trusted HTML, and then we can get into guiding developers towards tools that are known to have a good track record of producing trustworthy output. So, for example, an HTML sanitizer produces trusted HTML. A template system that does contextual auto-escaping is a trustworthy producer of trusted HTML. And if the template sees the trusted HTML, then it doesn't need to do extra escaping. So these security measures kind of compose nicely. Yeah. So there's template. Sorry, go ahead.
So you were talking about having modules that actually do these things. From what we learned last week, there's 850,000 of these packages for at least on the Node.js, the npm repo. Are there not already packages or established practices out there that are doing this, or is this an example of, XKCDs? We have 14, standards. Mike's trying to create another standard that's going to unify everything. Now we have 15 standards.
There's a little bit of that. So first, let me say NPM has a hugely difficult problem.
Yeah.
Yes, there are existing packages. So for template systems, there's Pug, which is widely used on the client. There's Polymer and React. So I've done hardening work on Polymer, which the Polymer team is largely Google employees. I've done some initial work on trying to harden React. There's Pug templates on the server that I've done hardening work on. And then if you want to talk to a database, you might use MySQL or Postgres, or if you're using one of these NoSQL, there's alternatives there. But for each of these, we can identify a class of attack that we want to avoid. So for Pug templates, how you generate your HTML plays into XSS, it plays into CSRF, and it plays into a number of other things. For example, if you want to use content security policy, it helps to be able to put nonces in the right place automatically instead of having developers getting into the habit of sprinkling nonces throughout their code.
Right.
For CSRF, you want to add tokens to forms rather than having developers sprinkling those throughout their code.
Mm-hmm.
So first we identify modules that probably participate in an attack, and then the hardening part is making it so that they fail safe, and in some cases making it more ergonomic and doing things like threading these contract types through.
Mm-hmm. Okay. Let me see. Go through this. So you have a attack review test bed on GitHub that you appear to be setting up some kind of vulnerable Node.js application, but this is different from that, right?
Yeah, so this is I've done work on hardening SQL, database interface libraries, HTML generation libraries, and libraries that deal with the shell. Mm-hmm. And threaded these contract types through. Then I've come up with this security infrastructure, the hooks that affect how modules load, and I've integrated all of that into an app. And the idea is the app is trivial to, if it were not for this security machinery, then the app would be trivial to pwn. It's vulnerable, 10 different ways. It uses common kind of naive practices, the kind of thing that developers they look at it, they know not to do it, but they don't not do it consistently. And so, so this app it should be easy to attack. But if the mitigations that I've got in place are working correctly, then it should nevertheless not be vulnerable. So it's integrating a lot of different ideas. And what I'd like to do is I'd like to invite Node developers and security specialists, your pen testers, other security engineers, anybody who wants to hack on stuff, to attack it and tell me how it goes. And then if it comes through with, if it survives the attack without huge structural changes, then I hope to go to the Node Technical Steering Committee and try to convince them that we have these suite of techniques that can get us to a better place. Nice. So if anybody is, you're with your in-laws, you've made all the cookies that you want to make, you've eaten all the cookies you want to eat, and you're kind of need a little bit of space from your in-laws, you can hack on it.
Yeah. So one of the questions I had, you're working on just the back end. Are you doing any kind of work to because anybody can just install any package they want, and that's dependency hell is one of the things that we discussed last week. But are you doing anything on the dependency side? It's like, well, you don't need 850 dependencies. You can just use this version, this package instead of this package, and save yourself a couple of hundred things. Is there any kind of hardening in that respect to reducing the number of software packages? Sorry.
Kind of general code cleanliness.
Yeah, general code cleanliness. Yeah.
No, I've not done anything along those lines at all. I think you're right. If you've got 5 different modules that are kind of all serving the same purpose, then probably at least one of them has errors that might have security consequences. But no, my focus has been not on reducing the amount of code that you put into production. Although with the resource integrity checks, it does, like your node modules tree often has, it has production code, and then it has runtime tools, and maybe it has test code for modules that you would want to run in production. And so the resource integrity stuff does a good job of making sure that random test code is not it can't be loaded in production, even if it's present on the machine. But no, I've been focused on letting people say that for a particular class of attacks, we need to bound the amount of code that might participate in that attack to a reviewable amount. Okay.
Apologies. I had to make an edit there because there's some crappy audio that I accidentally clicked on a link. So, well, that's pretty awesome. Okay, so the other thing is that I'm worried about with the approach to any of the stuff we're doing with Node.js is developers like their freedom, and what you're proposing and what was proposed in our last podcast was that we're going to start restricting that, which they don't seem to like. It seems to be a bit of anathema to them. So, how do we get them to buy into this new way of doing things without it completely ruining a lot of their workflows or restricting their freedoms?
So convince them it's for the greater good, right?
No, they just want to get out there. This is Uber new product. We need to be first to market. How do you tackle and fight against something like that?
Yeah, and so the kind of the kind of attitude where I'm a senior software engineer. I don't need training wheels. Right. Unsafe APIs are kind of what I eat for breakfast. Right. And you trying to keep me away from those unsafe APIs is just going to crimp innovation. Mm-hmm. And I think I think there's a certain amount of truth to that. So the first thing we have to admit is yes, these security measures do to some degree get in your way. Right. So what we've tried to do is try to use both a carrot and a stick. The carrot is we've come up with safe to use ergonomic APIs. So, for example, for the child process mitigations, preventing shell injection, what I did was I provided a template tag. So what you do is you write a shell string in a template tag, and it auto escapes any inputs, so that what appears to be a command is actually a command. They can't go in and start a new command. They can't cause a subshell where none appears in the original, and all those other kind of things that you do to solve these problems. And so that is easier to use than concatenating a string. They also don't have to, and so I'm actually removing the burden of escaping inputs from them. Same for the pub templates. It's auto escaping. Now you actually have to do less work. Because I'm using runtime types, if you pass in a string, it gets auto escaped. If you pass in a string of safe HTML, it doesn't get escaped. that means it is sensitive to the source. If you go to the work to make sure that something is marked by its runtime type as safe HTML, then you don't need to write this code like, should I remember to escape it? Should I not remember to escape it when it's down here? So, we've done a lot of work to try to make it easier to produce robust systems, and by making these tools easier to use than naive string concatenation. But at the end of the day, the thing that allows a team of engineers working together to produce systems with any property is that they all buy into that property and are all willing to do work. I think the biggest source of resistance is when somebody's onboarding. They're coming from a team to a new team. Maybe they used different practices elsewhere. And so where we can, we want to guide them towards safe practices instead of having them learn a whole new way of doing things before writing any code. They kind of just continue. And then when we notice a problem, we try to use that to point them towards the way of doing things. So if they take a response and write out a string by just doing string concatenation, then they find that out there. They don't have this whole raft of security process literature that they have to work through before they start coding.
Right. How prevalent is it, some of the OWASP vulnerabilities in Node? I mean, just the ones that you mentioned in your slides, and you're talking about cross-site scripting for the most part, which I could definitely see. How typical are things like clickjacking are still this is something that you put on a vulnerability report. UI redress or clickjacking is possible, but it invariably it's kind of hard to prove that that's actually a finding. So I mean, how bad is it that things like clickjacking exist in Node.js applications?
Yeah, I think clickjacking is a good example. It's really hard to manage because it requires reasoning about what multiple different frames are doing a lot of the time. So once you do move developers away from kind of ad hoc, concatenating a string to something like templates, you can start saying, where are all the iframes?
Right.
And once you consolidate the code that might, write response headers out to a, kind of carefully reviewed module, then you can start reasoning about, what headers are going to be what headers are going to be present on the response that affect how clickjacking works. But at the end of the day, these have to come down to judgments, and a lot of this work has been reducing the number of modules, the amount of code that has to be reviewed, so that we can spend scarce security specialists' attention on where it matters.
Right. Ms. Berlin, do you have any questions right now, or?
No.
Okay.
I asked the couple I had.
Yeah. So okay. So I do have another one while you were talking there. That should we have saw this coming? Should the developer community have saw this coming? That should they have had a bit more of a pessimistic view about these things when they were building this?
You mean event stream?
Well, not just event stream, but I mean JavaScript is in the browser. It's server side. There's going to be, all the OWASP vulnerabilities that they were dealing with in every other dynamically generated language, be it, PHP or whatever, is now inside of JavaScript, and they, didn't make the move to make these fixes back in the day. Why, is this something that we need to, how do we educate them on this so they don't do something for the next, Node.js like system in the future?
there's a literature on secure programming language design, how to design programming languages so that people who want to write secure code can do it. None of that. JavaScript is a language that has a long history, and that was not in. Brendan Eich, I think, was familiar with that literature to some degree, but I don't think he foresaw that JavaScript would be as huge as it was, or that we would have large applications built on it. I think he saw it as a small language that all of the code written would come from one source, and so the same origin policy would apply. And what's happened since jQuery came along and then Node.js is now JavaScript programs are no longer small tidy things that one person can wrap their head around, or even one team, and that's what's really changed. I worked on the Kaha project for a long time, which was trying to come up with a way of sandboxing JavaScript, the object capabilities for JavaScript. And those, similar work is still ongoing. So I think the eventual solution is got to be some kind of way of having JavaScript where one module can load another and know and kind of tightly bound what badness that second module could do. Okay. And I think that's going to but we're quite far away from that. I think Mark Miller's startup, the name I'm blanking on the name right now, but I can give it to you for the show notes later, is actually, I think, getting pretty close to something like that in Node. But it's going to be a while before we can say, hey, here's how you do it for a large application that uses module, kind of a large number of legacy modules. Mm-hmm. But I think the main kind of complication with dynamic languages is a dynamic language is one where, a string controlled by an attacker might substitute for a syntactic element. So it's got something like eval, which says just take this string and inline it as if it were code. Or it's got square brackets, which says, this interpret this name as if there was a dot, after it. And if you do dot constructor, that gets you back to something like eval. So that's the problem with dynamic languages is you never really know what code you're running, right? Unless you use these out-of-band mechanisms like resource integrity checks. Yep. So I think we've got to attack it from two fronts. One, make it so that, the kind of Mark Miller's approach, make it so that we don't care what that other code does, because we know no matter, worst case what it does, the worst case is it's going to give us back an output that might be useless to us. And the other is make it easier to bound what, code that is written in good faith, non-malicious code might do based on what it needs to do its job. Right. So that, even if this code is not malicious, but it's badly written, or there's a mismatch between the security needs of the application and the security assumptions made by the module, mm-hmm. That we can limit the downside.
Okay. So your framework and your hardening, is that available for people now to download if they'd like? I've been trying to avoid anything that would appear like I'm making a new framework. Oh, okay. I'm trying to come up with a series of things can be integrated into existing frameworks, and so we can actually lift the frameworks up and get them competing on, where they come up with these charts like, our framework has features X, Y, and Z, and others guys only have X and Y. We can get like, end-to-end XSS security, end-to-end
protection against server-side code execution, end-to-end security against SQL injection. We can get them competing on those feature points.
Okay. What? I was trying to figure out some quick wins that people can do, while they're waiting to, get everything implemented. Would it be something like, using strict, like they do in Perl or in other languages where there's restrict the functions or restrict the types of things that are being done? I was just thinking of the one there, but is there any other quick wins that they can do right now? When they get in on Monday morning, that could, help them, bolster even a little bit of their existing JavaScript environment.
So if they go, I think I imagine the link to the attack review testbed will be in your show notes or something. Okay. There's a set of libraries there that I put out that are hardened libraries, and so you don't need to adopt kind of, the whole bundle of things that I'm talking about. You can start using the trusted types Pug plugin to harden your Pug templates. You can start using, you can start migrating modules towards ones that use the safe Postgres wrapper if you happen to craft your own Postgres queries instead of using stored procedures or something similar.
Right.
If you're, you can start, you can give it a spin with the, sensitive modules hook. If you want to start, for example, locking down what has access to HTTP or what has access to child process, those kinds of things.
Okay. Is there anything that they can be done on the OS side, like, make Node.js run only on specific directories? Is there anything they can do on the OS level that would help, further strengthen the web application?
Well, anytime you run your server as a low privilege process, you prevent a whole bunch of problems.
Sure.
And so, if you typically you have something that unpacks your tarball with your source code, and then that runs with one user. If you can then run as a separate user, then your node process doesn't have access to your source code directory. Right. That goes a long way to preserving source integrity. Nobody can then just, if they can't escalate access, if they get arbitrary access, file system access, they can't escalate that into the ability to load arbitrary code.
Okay. Yeah, I was just trying to work all the way down. So, okay. So you're saying, go to this attack review test bed link, and there's some additional bits in there that can help shore up your Node.js. The second question I'm going to hear from my developers or from, my management is, will this break our existing workflows, or will it break something in production? I'm assuming you just don't want to drop these blindly into production.
No. And the answer is, this is, I crafted this test bed in part to figure out exactly how much it would break things in production. Yeah. And the answer is probably. For any non-trivial size application, it will probably break things.
Right.
And I, come up with ways to work around that. Part of, this is if the application under test survives attack, then I plan to use that as a reason to upstream tweaks to a number of widely used libraries to make it kind of so that it's much easier to do that.
Right.
But this is still kind of testing and proving stages.
Yeah. So, you can help Mike with his reviews or, making a better product if you could drop this into your test or development environment and see what it breaks. And really the only obvious workaround is to actually have the developers fix whatever it is that got broke, and so that it works with the system, not necessarily workarounds, right? Yeah. Cool. Okay. So there's a lot of links in our show notes to various speaking engagements that Mike did. One from jsconf.eu, the Node Summit, Nordic.js. Are you going to be speaking anywhere else? I would assume probably not the rest of this year, but is there any place else that you're going to be speaking in the next 3-4 months?
I might be going around and talking about trusted types, which is a proposal for client-side security. So, changing it so that if you opt in via feature policy header or something like that, then assignment to inner HTML, assignment to links, href attribute only work if the value is marked as trusted. And so that's taking this idea of, having values use types that indicate how they're safe to use, and moving it to the client. So that is moving its way through the standards bodies. I think it's the web, WICG is the web incubator. I forget, but it's part of W3. Okay. And so I'm going to be talking a little bit about that.
Cool. All right. Very nice. Let me put that link in the show notes to WICG trusted types. That's in there. There's also a blog post I found from the NPM.js people about trusted types. So plenty of information there. I'm probably going to take the thing out about packages. One of the things I found after we did the thing with Adam Baldwin was how many different types of packages can be in, for instance, in a package manager. And it was amazing how convoluted the whole list became because there's just so many ways of getting packages into the system. I can understand why there's 850,000 of them, at least in their node repo. Would you suggest that people run their own private node repos instead of just going out to some regular, that way at least you know what you're running in your own environment? Do you think it's a good idea?
Yeah, definitely. So that's a good idea in a couple of different ways. One thing you don't want to find that you're vulnerable and then have no way to fix it. So let's say you find that you're vulnerable because some deep dependency of yours does something silly. Maybe you figure out I don't need it to actually do this, and so you can come up with a several line patch to cut out the code or to fix the code. But if you have to wait for that patch to be upstreamed, then that increases your window of vulnerability.
Right.
So it helps with incident response. It also can help security specialists. So if you have a bunch of different project teams all working and they share one of these local mirrors, then what you can do is you can, when somebody adds a new dependency, a developer adds a new dependency that goes into a database and indicates that dependency has not been checked by security. And so security might, monitor that on an interrupts basis. Whoever's on call just, picks it up when they get to it. They look at it. They may say it's, non-controversial, or they may say, this is using crypto in weird ways. Why don't you use this other alternative? Or, try and upstream a fix. And so there can be this parallel workflow to development, which is security doing their kind of vetting, and that can be amortized over a lot of projects if you kind of have that local mirror. And another nice thing is that Adam Baldwin and his team might realize something terrible is happening. There's this vulnerable module or you find it internally, then you have a problem. You have to figure out which products need to, and this may be a big company problem, but you need to figure out which products are affected so that you can start the patch and push process.
Nice.
So kind of it being able to be knowing what your developers depend upon, and having a place to fix that problems is key. There's also a problem with it's been largely so far knock on wood it hasn't actually happened, but global, if NPM goes down when there's a security incident response, you may have the case that a fix has been pushed, but nobody can get to it because NPM is a single point of failure.
Right.
So you don't want to be denied fixes because NPM goes down, maybe because they have to pull the plug because there's a virus propagating across it. Mm-hmm. One way viruses could propagate is by post-install hooks. You pull something down, it looks in package.json to see a post-install that specifies a shell string to run. So if you have a local mirror, I don't know whether Artifactory or any of the other, whether any of the kind of services out there that do this, whether they actually do this, but what you can do is you can say, I need to build any of the native bindings for these architectures. And I don't want the post-install script to be able to use ambient developer privileges. So it shouldn't be able to look into the developers /.ssh. It shouldn't be able to use the fact that they're logged into Git. It shouldn't be able to use the fact that they've done an NPM login. So I'm going to, I have a dedicated machine where I run those post-install scripts as a low privileged user, and then gather, the artifacts and make them available to developer machines.
Cool.
And so, being able to downgrade and run post-install scripts in an isolated environment might isolate you from problems due to worms or malicious code in post-install scripts.
Right. So it does sound like that regardless if you don't do any kind of hardening, just running a local repo is probably a good best practice in the first place.
It wouldn't have stopped event stream.
Yeah,
but
true. That's true.
If the malicious code is actually running in production, then no local mirror is going to protect you, but it does put you in a better place.
Yeah, and the event stream stuff, only if you ran co-pay Bitcoin wallets on your servers, then would you have an issue. But so I mean, it was a fairly specific attack, so it only affected probably 99, less than 1% of the people. 99% of people probably didn't notice any kind of issue or change. So that was kind of an interesting little.
Oh, I was just going to say that the fact that it was a specific attack is, I think, why it went undetected for so long. Mm-hmm. So with a lot of these kind of malicious code things, I think unless they're they either probably attack for a very short period of time, or they attack for specific targets and so fly under the radar of the larger community.
Right. Yep. I mean, we're only scratching the surface, I think, with this Node.js stuff, and it's going to get probably not better before it gets worse than it already is. So, cool. All right. Well, Mike, I think we can probably be done now. Amanda, did you have any questions? Sorry. Did you have any questions before we go?
No, you asked one of the ones I was going to ask. So. Oh,
I'm sorry.
It's all right.
Yeah.
I'll just sit here. I'm being attacked by wasps, so I've been just looking over. I killed one of them.
Where do you live? You live in some boonies or something? What's going on?
I live in I do.
Okay. All right. Well, we better let you go so you can go get your Christmas cookies made. So, Mike, if people wanted to discuss more about hardening Node.js or getting involved with the initiatives you discussed, how would they go about doing that?
So they can talk to me on Twitter. I accept direct messages. Also, if they go to the test bed, there is a link there to a Slack channel it's actually under the Node Security Working Group Slack.
Okay.
And so I monitor that.
Okay. What kind of questions can they ask in the Node security Slack? Can they ask like general help questions, or is it like you guys have a specific purpose for that Slack?
So the security working group, the general Slack, is for talking about vulnerabilities that affect the larger Node ecosystem and kind of security working group business. It's not free consulting.
Yeah.
For the hash attack review Slack channel, I'm happy to talk to anything related to the attack review or kind of hardening Node.
Okay. Cool. All right, excellent. Yeah, we'll put that link in the show notes. I know it's at the bottom of your attack review bed area, so we can definitely add that.
Yeah, the README is a big wall of text, but if you scroll down to getting answers to questions,
yep, that's all right. It's a lot of good information though, so it's important. All right, so. And that's your Twitter handle is MVSamuel on Twitter, so they can reach out to you there. Cool. Okay. Ms. Berlin, if people wanted to, get in touch with you about, helping to, set up monitoring to harden after they harden their Node.js or whatever, what would they do?
So Twitter is, or our awesome Slack channel that keeps growing, is at Infosystir, INFOSYSTIR.
Cool. Yep. We have a fairly active Slack channel with all kinds of stuff. We have a web app channel, so you can go in and ask those general questions maybe that you won't be able to answer in the Node working group there.
I cannot keep up with all of our channels that we have now.
Well, I just try to, make sure it kind of self-polices itself. So it's an important thing. We don't have people who are running amok, and people tend to self-police, which is nice. Yep. Haven't had to ban anybody yet on the Slack, but I did on my local meetup. Somebody started spamming like free giveaway links. So
nice.
They were deleted. I did not give a warning, which is how it happens in the Slack. If we have a social contract, and if you can't follow that social contract, we'll ban you. And
we'll laugh about it afterwards.
Well, we'll laugh in a haughty manner, but yeah. Anyway, so you can, if you want to join that Slack channel, we have about 400 or 500 active users on a regular basis. If you're interested in joining that, you can send us a DM on Twitter. We are at Breaksec, BRAKESEC. If anybody asks you a question like, "Hey, what's your interest in InfoSec?" it's probably because we don't think you have enough followers, and we're worried about you being a bot. So just kindly answer the questions. And, if you pass muster...
I feel like several people have created Twitter accounts just to ask for the Slack link.
Yeah. And, they can email us at bds.podcast@gmail.com to, get one if they don't have Slack. I get that, But yeah, it's, sometimes it'll be like, hey, I need an invite to the Slack. And I'm like, hi, no followers, no poster, no Twitter.
Mr. Yeah, has an egg as a profile picture.
Yeah. I mean, what's your interest in InfoSec? And then, if they reply back, great. Otherwise, I don't give them an invite. So, but yeah, so you can join us on there. One of those two methods, Twitter or email. We have a Patreon if you found value in the last, year's worth of podcasts or better. Please feel free to leave us some money over there. Even $1 is, goes towards our Zoom, goes towards hosting fees. It goes towards time for processing and, being a Slack moderator. So we appreciate that. You can follow us on iTunes, iHeartRadio, TuneIn Radio. Somebody just told me the other day they saw us on Spotify. So that was great. We're on Spotify. you can hit us up there. Please feel free to leave feedback on any of those platforms to, help us get additional, what is that? What is that word? Additional
followers, subscribers,
downloaders? Yeah, or notice, additional notice. So yeah, there you go. Yeah, so I think we only have one more episode this year, and it'll be like a short one, just like a year in review kind of thing with some, maybe some news or something, probably closer to the end of the year. But Ms. Berlin, go and enjoy making your cookies. If you could send me some, that would be great. I'm woefully short on the Christmas cookies this year.
As soon as you send me some gummy bears.
I don't have gummy bears in the area. They don't have them like that. Anyway. All right, well... that was it for our this week's episode of Breaking Down Security. Thank you, Mike, for coming. And, if you guys have any breakthroughs or anything, on how to, anything comes out of the working group or there's anything else you'd like to discuss with Node.js, I'm sure there's a lot of people out there who are champing at the bit for discussion of that. So if you ever want to come back on, please hit us up.
Thanks so much for having me on, and I'll see if I can't find my way onto your Slack channel and maybe see if people have questions there.
Cool. Yeah. All right. Sounds great. All right. That's it for this week. Have a great week. Be nice to one another. Take care of yourself because you're the only you have, and we'll talk to you again soon.